Example 8-1. The river having a channel whose the cross-section is shown in the accompanying figure is subject to the flood 10,000 cubic foot per second. Find the velocity in the overbank area and in the main channel. Okay, at the station 0 and 600, if the depth shown occur at the station 0, manning n is 0.05 and overbank area is 0.03. In the main channel, the slope is the 0.00167. Okay, so this is given information Q manning n for main and manning n for overbanks. Slope is equal to this number, and in this case we're going to use the standard step approach to find the solution. This means we will start from fixed distance and find the depth. Okay, from calculate depth, find the velocity and depth at the station 0 and 600. Okay, so we start from the write the total here, the equation between two sections. You can say that this is for part we divided. This part is part A. This is for overbank area. And part B is the main channel. Okay. You can write equation for energy equation as two section for section 0. Okay, friend. Sum to depth and velocity to be the specific energy E naught plus the okay, in this case for the S naught times the x is equal to delta x is 600 equal to 1/5. Okay, and next we start to first station at station 0. We calculate each parameter and put in the table later. Okay, so we find the area A is combined from this is from the main channel. The depth is the width is the 100 times the depth is 5, and for the overbank flow is the 100. No, the left hand side is for the overbank flow and the right hand side is for the main channel. Okay, so this one is 5 feet and this is 10 feet. 10,000 100. Okay, so the area is total area is 1,500 square feet. For part A, for weighted parameter is 100 plus 5, 105. For B is the 5 plus 110. For PB. And for the header radius, thousand divided by 105. radius for part B is equal to this one. We just take the average, take the power. If A is power 2 over 3 is about, and for the radius for part main channel, power 2 divided by 2 over 3 is 4.23. And next we estimate the KA. Time area time for K is equal to 4,000 22 42,000. From equation x11 we can estimate alpha equal to the summation of area power 2 divided by summation of K. So how to get this 97.6 10 power 8? It comes from this table. Okay, so this one we substitute our parameter that we calculate parameter in this for the station 0. Okay, so we got this for hydraulic radius square for remaining n and for K. Okay, and for this one is the K power 3 divided by area to power 2. We got the summation is about 90.7 10 power 8, and we bring this for summation of the column 10. Okay, so we put here 97.7 10 power 8. Okay, and finally we got the alpha is 1.342. Okay, and we can finish this. And for V, average velocity is equal to 1000 divided by total area, because 6.767, and V square velocity tau alpha is equal to it should be not made per second, it should be feet. And E is equal to, and finally we can find the friction slope. Okay, so we put together everything in this one. So now we got the final the solution for the friction slope for the first section, and the section 0 is about 0.00155. Okay, and the next we do another section. So we have to do many iterations. We have to assume the depth of the on O-bank flow and the main channel. Okay, and we do this. We follow the same step from the station 0, and finally we can estimate what is the rate of friction slope and take the average. Okay, this means we do the same until we get this slope 0.00128 and get to find the average S friction slope. Okay, and the next we find the time friction slope with delta x. We got this number and find the difference of energy between two sections. So we got the negative 0.23, so it's not equal to 0, so we have to try again for the new second iteration. Assume the new for the new y. Okay, increase it a bit, and we check the average friction slope again. We prove that data is negative, still negative. Okay, or is more negative. So it should be direction is wrong. So we try the iteration. Y is 5.2 and 10.2 feet. We prove that delta E is negative 0.05. Prove that is less. Still on direction less negative. And we try to fourth. Okay, so we prove that this is okay for y is equal to 5.1 and 10.1. So it's come to the last iteration that we try the depth 5.1 and 10.1, and the final the difference of energy is almost zero. Okay, that is a final to prove that this corrects the depth at the station 600. Okay, the other thing is that we can check at the V6. We use the final depth to find the velocity. This one is hydraulic radius, okay, and time the friction slope. The same for VB velocity on the main channel. And we check Q for this area time velocity. Area time velocity. Why? Something wrong. Why is coming? We prove that Q is a bit higher than, is greater than 10. But we prove that because some error of due to the lack of the precision in calculation